Hi, welcome to my channel. So, today I am going to explain an important concept in Newton laws of motion is nothing but constraint equations. So, this constraint equations plays an important role in IIT JEE mains. Okay, now I am going to explain some information regarding constraint equations. First of all, see here what is meant by constraint. See here constraints. So what is meant by constraint? Okay, constraint means here to oppose the motion of the body in any direction or the restriction of free motion of a body in any direction is called constraint. See here, what is meant by constraint here? Constraint means the restriction of free motion of a body in any direction. So constraint means the restriction of free motion of a body in any direction is called as constraint. Okay, next one word is constraint equation. Constraint equations. So what is mean by constraint equations here? So constraint equations is nothing but the equations showing relation of the motion of the motion of system of bodies in which one motion of the body is constrained by motion of the another body is called constraint equations. Okay, let us see here. Constraint equations means the equation showing relation of the motion of system of bodies in which one motion of a body is constrained by the another motion of the body is called as constraint equations. So in this condition, one motion of the body is constrained by the another motion of the body is called as constraint equations. So these constraint equations are classified into four types. Now let us see what are the four types here. Types of constraints. Okay, the type of constraints are classified in four types. General constraints. Okay, next one is pulley constraints. Next one is wedge wedge constraints, and fourth one is mixed constraints. Mixed constraints. Okay, let us see here general constraints. General constraints means let us assume any one floor. On the surface of the floor, we are going to place a block. That block is constrained by this floor. Some of the kinematical quantities like as velocity, acceleration, displacement, those are constrained by this surface. This is called as general constraints. Let us assume. Next one is pulley. Let us assume 2 or 3 bodies are connected with the help of the pulley. Okay, here one body, that is a 1, 2, 3. Now maybe body 1 is constrained by body 2, or body 2 is constrained by motion of the body 1 and body 2, or body 3 is constrained or strict the motion of the block A, block 1 or block 2. So in this manner, pulley constraints. With the help of the pulleys, we are going to restrict the motion of one body with respect to the other body. Next one is wedge constraints. Wedge constraints means let us assume a wedge. That one makes an angle theta. Inclined plane makes an angle theta with the horizontal. This is called as a wedge. On the surface of the wedge, we are going to keep a block. On the surface of the edge, we are going to keep a block. This one is moves in downward direction. That motion of the body is depending upon wedge. And if block is moves downward direction, if there is no friction between this wedge and surface, this block is moves backward direction. This velocity or acceleration or displacement is depending upon this one, block A, and this block A velocity, displacement or acceleration is depending upon this one. So the motion of this body is constrained by this one, and motion of this wedge is constrained by this one. So this is also another example for wedge constraints. Next one is mixed constraints. Mixed constraints is nothing but wedge, and now we are going to arrange one pulley. Over the pulley we are going to keep one body here, we are going to arrange one more body here. So block A and block B. Now if there is no friction between these two, maybe the wedge moves backward direction, if it is moves downward direction, this wedge's backs move opposite direction. So these are the pulley inclined planes, wedges all are mixed. That's why it is called as a mixed constraints. So constraints are classified into 4 types: general constraints, pulley constraints, wedge constraints, and mixed constraints. Clear? Okay. Now we are going to explain about first general constraints. General constraints. Okay. Let us see here. One block of mass m, which is placed on a rough surface or any one surface. Here some of the kinematical quantities are restricted by the kinematical quantities of this body is restricted by this flow in vertical direction. Okay, this body is placed on the surface of the body, surface of the plane or rough surface, whatever it is. So this rough surface or this surface obstruct the motion of this body in downward direction. So what are the kinematical quantities along the downward direction? Maybe displacement along the y direction, that is equals to 0 because it is placed on the surface. It is stopped. The body has been stopped. There is no chance to move downward direction. Okay, right. Next one is velocity along the y direction is equals to 0. And acceleration along the y direction, that is equals to 0. So some of the physical quantities, kinematical quantities are restricted by this flow. Okay, in this condition we are going to observe that flow restrict the motion of this body. Okay, this is one of the example for general constraints. Okay, next one, let us see. Let us assume 2 bodies, block A and block B. These 2 bodies are connected with the help of a light inextensible string. That means that string does not expand. Okay, so light means here massless. The mass of the string, let us assume 0, and in extensible, inextensible. There is no elongation along their length. Okay, right. This is placed on a surface. Okay, now I am going to apply a force F on a block B. Sorry, block A. Now I will apply a force F on block A. So by the application of force, this block is covered by a distance x. The block A is covered a distance x. Now what is the distance covered by the block B? So here the distance covered by the block B also same x distance. Same x distance. This is covered a distance x. So because this in between the two bodies are connected with the help of a inextensible string. That's why the distance covered by the block A is equals to the distance covered by the block B. So let us assume some points. For example, point here, and there is one more point. This is another point. This is another point. Okay. Now let us assume this is a point P1, point P2, and point P3. So here the distance covered by the point P1 also x. The distance covered by the point P2 also x. The distance covered by the point P3 also x. The distance covered at this point also same x only. Because the distance between each and every particle also remains constant. There is no any change distance between any two points. That's why the distance covered by the block A is must be equal to the distance covered by any point along their length also same. Okay, that means finally we are going to conclude that distance covered by the A is equals to distance covered by the particle B. Okay, now I am going to differentiate on both sides with respect to t. Now dxa by dt, that is equals to dxd by dt. Here xa and xb are the displacements. Distance or displacement along the line joining along a straight line. So that's why the rate of change of displacement is called as velocity. This is a va and this is a v. Okay. At the same time, differentiate on both sides with respect to time for velocity. Again, we are going to get dA by dt, that is equals to dv by dt. Finally, I am going to get the A is equals to A. That means here by observing this activity, this example, we are going to conclude that the distance covered by the point block A is equals to distance covered by the block B, and velocity of the block A must be equal to velocity of the block B, and acceleration of the block A must be equal to acceleration of block B. Not only these two blocks, let us assume any particle in between along their line joining, along their length of the string also. So every particle along their length, displacement, acceleration, velocities remains constant. Okay, remains constant. Here, the relative velocity between P particle P1 and P2 is equals to 0. The relative velocity between particle P2 and particle P3 is 0. The relative velocity between block A and block B also 0. So, for example, same VA is equals to AB means, let us assume this is a particle moves with an acceleration. Let us assume here. Let us assume. So this is the block A, this is the block B. This block B is moves with 5 meters per second. Now tell me what is the velocity of the particle B? Particle B also 5 meters per second. And let us assume this is the point A. Okay, small a. This is small b. Now what is the velocity of the particle A? Velocity of the particle A is equals to 5 meters per second. Now what is the velocity of the particle B? That is also 5 meters per second. Okay, here relative velocity. Relative velocity means velocity of the A with respect to B, that is VA minus VB. That is equals to 5 minus 5, that is equals to 0. So relative velocity VAB is equals to 0. So finally what I am saying is here, the velocity of the each and every particle along their length are equal. Whatever it is the points along their length. So for all particles, the acceleration, displacement curve and velocity of the particles are remains constant. By using that word, we are going to solve more problems. What is that word? So the velocities of a any point along their length of the string are equal. So these are the important points regarding strings. Okay. At the same way, let us assume two blocks here, block A and block B. These two are connected with help of a rod, iron rod. This iron rod also light and inextensible. Light and inextensible, let us assume. Light and inextensible. Light means the mass of the rod is negligible. Actually there is a mass, but we are assuming negligible, and there is no expansion along their length. Here also, this is covered at distance 5 meter per. It is moves with a particle or body or block A moves with 10 meter per second along the horizontal direction. Now, what is the displacement covered by the particle B? So, sorry, this is velocity. Velocity of the particle B also 10 meter per second. Let us assume one point here. So, point P, point P1 and point P2. Here, the velocity of the particle P1, point P2, point 3, P3 also 10 meter per second. So, the velocities along the lengths are equal. At the same way, not only velocities. Here, distance covered by the block A and distance covered by the particle P1 and distance covered by the particle P2 and distance covered by the particle P3, that is equal to distance covered by the particle B. All are same. Same manner differentiation with respect to time. All of we are going to get VA, VP1, VP2, VP3, that is equals to VB. So VP means those are the particles. Particle 1, particle 2, particle 3. So sorry, P1, P2. P1, okay, let us assume P1, P2, P3. Okay, now here again differentiation we are going to get AA, that is equals to A P1, A P2, that is equals to A P3, that is equals to AB. So all are same along their length. Okay, clear? Okay, let us see one more example. This is the wall. Let us assume a ladder or an iron rod. A ladder or an iron rod which is arranged in such a manner. So this is the x-axis, x, and this is the y direction. Let us assume. So this rod or ladder makes an angle theta. Okay, let us assume the end. This is the one point P1, or let us assume point A. One end, or let us assume one point at the one end of the iron rod. Let us assume there is one more point B at the other end of the rod. Okay, let us assume one point at one end of the rod, and there is one more point at other end of the rod. So let us assume this point is moves with the VA velocity along the horizontal direction. Now I am going to calculate what is this point, velocity of this point in this direction. So what is the velocity of the point B? So generally you know that this is moves in this direction. This is moves in this direction. Automatically the particle is moves downward direction. with a velocity v. Now what is the velocity? Vv. Okay. Now let us assume here. Let us assume this is moves along this horizontal direction. Now I am going to resolve this velocity in two components. So we have one formula, that is the velocities along the velocities of any point along the line lines are equal. Okay, for that one I am going to resolve this velocity in two components. This is one component. Okay. Okay, this is arithmetic angles are equal. That is VA cos theta. Next we are going to divide one more component, perpendicular components. This is VA sin theta. Okay, let us assume here this is the angle 90 degrees. Now what about this angle? 90 minus theta. 90 minus theta. So now let us assume this is the velocity downward direction. Okay, this is the velocity downward direction. Now this velocity can resolve into two components. One component is along the length of the string. That is this is the angle. So VB cos 90 minus theta. And there is one more perpendicular component. This is VB sin 90 minus theta. 90 minus theta. So according to this definition, the velocities along the line lines are equal. So this is the any point along the line lines. This is VB cos 90 minus theta, that is equals to VA cos theta. Now VB, what we call cos 90 minus theta, cos 90 minus theta is equals to sin theta, that is equals to VA cos theta. I want VB. Now VB velocity of the point B is equals to VA cos theta by sin theta. Now VA cos theta by sin theta can be written as cot theta. So VB is equals to cos theta. So this is the one of the way we are going to calculate velocity of the particle B. Okay. 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 The same problem we can explain with another model. Okay, see here. This is the wall and horizontal. Let us assume this is the rod of length L. So this is the one end, this is the other end. Let us assume this is the distance x from the horizon, and this is the distance y from the horizon. So one end is placed at this point, another end is placed at this. The point A, this is the point A, let us assume this is the point B. The point B is y centimeters height from the horizon, and point A is x centimeters from the horizon. You know that this is moves in horizontal direction with velocity Va, and automatically this is moves downward direction with velocity V. Okay, this condition let us assume now x is increases. What about y? Y is decreases. So x is increases, y decreases. That means x is change variable and y also variable. But length of the rod is remains constant. Length of the rod is remains constant. Okay, let us see here. According to right angle triangle. Okay, Pythagoras theorem. According to Pythagoras theorem, x square plus y square, that is equals to L square. Here L square is nothing but constant. Now here we are going to differentiate on both sides with respect to time. That is x square plus y square, that is equals to dl square by dt. Now I am going to write this one, dx square by dt plus dy square by dt, that is equals to dl square by dt. dl square by dt. Here this can be written as 2x dx by dt plus 2y dy by dt, that is equals to 0. Why you consider 0 here? L square is a constant. Differentiation for any constant value is equals to 0 itself. Now I am going to write here 2x dx by dt, that is equals to minus 2y dvy by dt. So what we call rate of change of displacement? Velocity. So now 2x, x means I am going to consider va. So va, that is equals to minus of 2y v. Now 2 gets cancelled. So minus indicates opposite direction. One is moves along the horizontal, one is vertical down. That's why opposite. So now I am going to take only magnitude. xva is equals to yvv. I want the vv. So velocity of the vv is equals to x by y va. X by y va. X by y va. Okay, let us assume here x by y. So according, this one is the angle theta. So according to this angle, x by y means adjacent side by opposite side. Adjacent side by opposite side means cot theta. Opposite side by adjacent side tan theta. Opposite side by hypotenuse sin theta. Adjacent side by hypotenuse cos theta. But adjacent side by hypotenuse cot theta. So VB is equals to VA cot theta. See here, this is also one of the way to calculate the relation between VB and VA. So see here, this is also VA cos theta, this is also VA cos theta. So this is the one of the method to calculate. Okay, right. Next one, see one more example. Let us assume this is a pulley. One pulley is connected. Okay, this is a bracket. This is black wick. Okay, this is black wick. This block is moves with velocity v1. This is block moves with velocity v1. This one makes an angle theta with the horizontal, and this one is moves with velocity v2. Now what is the velocity of v2? So this block is moves with the v1 with the horizontal. The horizontal makes an angle theta. This thing makes an angle theta with the horizontal. This block is moves in this direction. Okay, now what is the velocity of the block? What is the velocity of the block? Here let us assume there is a one point. The velocities along their lengths are equal. The velocity along their lengths are equal. Let us assume this is the velocity one component. This velocity can resolve into two components. This is velocity v1. So this can resolve. This opposite angles are equal. This is theta. This can be considered as v1 cos theta. And perpendicular component. This is v1 sin theta. Okay. So this is so the velocities along their lengths are equal. This is one velocity and this is the other velocity. From this figure, I am going to write v2 is equals to v1 cos theta. So this is the velocity of the block A. Okay, understand? Okay, right. Let us assume one more example. This is block A, this is block B. This one moves with the velocity v1. This one makes an angle theta1 with the horizontal, and this one makes an angle theta2 with the horizontal. And what is the velocity of this is moves in this direction. Now what is the velocity of this block? So the velocities along the line joinings are equal. So this one can resolve into two components. This is one component, that is VA cos theta. So for that perpendicular, this is one more component, V1 cos V1 sin theta. So next this one we are going to have converted into two components. This is one of the component. This opposite angles are equal. This is V2 cos theta 2 theta 2. This is theta 1. Next one another component, vertical component, perpendicular component. This is V2 sin theta 2. So the components along the lengths are equal. So this is the one component V1 cos theta 1, that is equals to, so V2 cos theta 2. Now V1 is equals to V2 cos theta 2 by cos theta 1 relation. Otherwise, so we need V2. V2 is equals to V1 cos theta 1 by V2 cos theta 2. So this is the relation between velocity V1 and velocity V2. Okay, let us see. See one more problem. So this is one table. On the surface of the table, we are going to keep a block wave, and there is a one pulley. Over this pulley, there is a one more block. Let us assume one more block width. Okay. Otherwise, you have to take like this. Okay. This one makes an angle 53 with the horizontal, 53 degrees. Okay. Now this block is moves with the velocity 5 meters per second. Block A. Now what is the velocity of block B? What is the velocity of block B? Now we need to calculate here. Okay. In this condition, this velocity, this is nothing but velocity VB. This can resolve into two components. One component is along the direction of the string. So this is so VB cos 53 degrees, and this is the one more component, perpendicular component. This is VB sin 53 degrees. Okay, these are this velocity VB along this direction only. It is moves along this direction. This is the VB. This VB can resolve into two components. One is a VB component, VB cos 55 along the horizontal, along the line joining line, and one more perpendicular to the component of this one. Okay, these are the two rectangular components. Okay, next one, there is a one component phi. According to our definition, the velocities along the line joining between the 2 points are equal. Here, whatever it is, that is equals to 5 meters per second only. Here, that 5 meters per second is equals to VB is equals to VB cos 53 degrees is equals to 5 meters per second. 5 meters per second. So now here VB into what is the cos 53 value? Cos 53 is equals to 3 by 5. That is equals to 5. Now here VB is equals to 25 by 3. That is equals to okay, 25 by 3 meter per second. Okay, 20 by 3 meter per second. That is the velocity of the block B. So whatever it is the circuit, in this condition we are going to assume what are the components or what are the component of velocities along their strings are equal. That's it. Okay, let us assume one more question. This is one rigid support and this is another rigid support. In between the two rigid supports, we are going to take one rod, iron rod. For that iron rod, we are going to connect or arrange one ring. What we call here ring. One ring is arranged in such a manner. Okay, that ring is connected over the pulley. So this is connected, and over the pulley, it is connected to the block. Okay, block A. It is moves downward direction. It moves downward direction with the 10 meters per second. It moves downward direction with the 10 meters per second. Now, what is the velocity of this ring along the rod is? Along the rod is. Here, that one makes an angle 53. Let us assume makes an angle 53. That ring makes an angle 53 with this thread. Okay. Now I am going to calculate the component. This is the velocity along their rod. This is the velocity of the ring. We are going to calculate. Now this velocity of the VR can result to two components. One component is along the thread or string, that is VR cos 53. There is one more rectangular component. This is the rectangular component. That is called VR sin 53. VR sin 53. So now we know that the components along their line joinings are equal. This is the 10. Here 10, here 10, here 10, whatever it is, all are 10 soon. That means VR cos 53, that is equals to 10. Now here VR, velocity of the ring, VR is equals to cos 53. Cos 53 is equals to 3 by 5. Now this is the 10. Now VR is equals to 50 by 3 meter per second. Meter per second. So this is the one of the example. Okay. Let us see here one more example. Let us see here one more example. Let us assume this is a one type of arrangement. Okay. Okay, this is the pulley. Over the pulley, one body here, one body here. Okay, this one makes an angle 53 degrees. This one makes an angle 37 degrees. 37 degrees. So this one moves with the velocity 10 meters per second. So what is the velocity of this bar? This is VA. This is V. Now I want to calculate what is the velocity of the bar. Here also same formula we are going to calculate. So the components of velocities along their length of the strings are equal. So this one can resolve into two components. This VA can resolve into two components. So already angles are equal. That is, this is also 37. One component is this one. That is 10 cos 37 degrees. This is one component. So another component is this is 10 sin 37. So this 10 meter per second can resolve into two components. This is one component, this is another component. Next, this one also we are going to calculate. That velocity of the block is this direction. This is the VB. This VB also can resolve along the string is one component. This is 53. That is VB cos 53. And there is one more component. This is VB sin 53. Now the velocities along their line joint along their lengths are equal. That means this is 10 cos 37. That is equals to VB cos 53. Now 10 into cos 37 value. What is the cos 37 value? 4 by 5. That is equals to VB. We need to calculate. Cos 53 value 3 by 5. Now 5 gets cancelled. Now VB is equals to 40 by 3 meter per second. So in this manner we are going to calculate the velocities of the one body with respect to velocity of the another body. Okay. See here, I think very